Here we're looking at a review of our statistical data analysis. We're going to be dealing with mean, median, mode, range, and also finding quadratic and linear patterns, and dealing with circle graphs, histograms, and bar graphs. Our first scenario here, they give us a set of information that are the various fat grams of food items at fast food restaurants. So looking here, here's our list of data here. Our list of data from here to here. And there are lots of different ways to go about the mean. The mean, we go through and we find the sum of our data, and then we divide by how many items there are. Luckily, we have nice technology that helps us with that, and that's our graphing calculator. In the graphing calculator, I can take and hit Stat, and then Edit, and I can go and input all of my information. I've already done so here. I have every one of our data items in here. I can get out of here, and I can now go and calculate my mean by hitting Second, Stat, and going to Math. And here in the Math section, notice I have min, max, mean, median, a whole bunch of different options. I'm looking for the mean. That's number 3. The mean of what? Well, the mean of L1. L1 is where I stored all of my data, and I press Enter, and I find that my mean is 22.1 grams. That is the average number of grams of fat in our fast food items. I now look for the median. The median again can be calculated using our calculator. So I go in and I hit Second Stat again. I move back over here to Math section, and I look here, median is number 4. Number 4. And again, I want to find the median of L1. So I press Enter, and the median is 21. That's the number in the middle. If we list them in order from least to greatest, that would be our information. And the calculator actually will even list our data in order from least to greatest. If I tell it to go in here and say sort, I want to sort it in an ascending order, and then tell it to do L1 and press Enter. Now whenever I go into my statistical register and hit Edit, notice all of my data is sorted from least to greatest, least being 9 all the way up to the highest being 41. I'm now looking for the mode. The mode is the one that shows up the most often. It's the number that's repeated the most. I see that 15 has been repeated twice, and I go through and I survey my data, and I see that no other number has been repeated. So therefore my mode is 15. I now need to calculate my range. Well, the range of the data is by taking the largest number and subtracting the smallest number. Well, my largest number here, since I have sorted them, is 41. And then I'm going to subtract the smallest number. Well, the smallest number in my data set is the top one, since they have been sorted, which that's number 9. So I do 41 minus 9, which is 32. We have now just done mean, median, mode, and range. Looking at our next set of problems here. Here, it says Jake Thompson decided to run for student body president. The frequency table below shows the supporters in each class, and draw a histogram to show its frequency. To draw a histogram, here along the side we're going to put the frequency. Along the bottom here, we're going to go through and list each of the students. My frequency, my highest frequency here is 200. My lowest is 70. I'm going to go through and make marks on here, counting by 50s. Try and make them as even as possible. Remember, with histograms, we want to go through and make sure our bars are connected because it's a fluid set of data. Next, I'm going to put here at the bottom the freshman. Our freshmen, we would come over here, 70 would be approximately here. Next we have our sophomores. The sophomores would come up a little higher. It's at 140, so it's about double the size. Sophomores. Our juniors are at 200, so that's the highest supporters. And then we have 175 for our seniors. Notice there are no gaps in our histogram. Histograms do not have gaps. They show fluid data, and they have our frequency along our vertical axis. What group does Jake have the largest number of supporters? Well, that's the one that has the highest bar here, which would be our juniors. Our next question asks, if there are 563 students in the junior class, what percent of the class supports Jake's student body? Well, we know that 200 of the students support him, and there are 563 students in the class, and then I can multiply that by 100 to change it to a percentage. So we pull out our handy dandy calculator here. I get back to my home screen and I do 200 divided by 563 and then times 100 to make it into a percentage, and I get 35.5, but it says round to the nearest whole percent, so we would say approximately 36% of the students support Jake. Continuing with looking at our graphs and whatnot, we have a bar graph here. It says Mr. Fox did a random and unbiased poll of the students of AMCHS. He asked, what is your favorite ice cream? The results of our 160 students shown. So again, anytime you have information like this given, it's always good to highlight it or underline it. The 160 students shown in the bar graph use the graph to answer our question. So what is the favorite ice cream of the most? What flavor of ice cream had the most amount of responses? Well, that's going to be the highest bar in here, which would be vanilla. What flavor of ice cream has the least amount of responses? Well, that's going to be the lowest bar here, which is mint chocolate chip. So mint chocolate. Looking down here, it says if there are 2,250 students at AMCH High School, then how many students favor ice cream that is strawberry? So we need to first figure out, we have strawberry. There are 28 out of 160. So we can set up 28 out of 160 and find out what proportion of those out of our 2,250 students would like strawberry. Remember, with these like this, you can basically say, hey, X is here, and treat this with our cross multiplication. So I'm going to do 28 times 2,250. Then I'm going to divide it by 160 to find out how many students that would be. So I get my calculator and I do 28 times 2,250, and then divide that by 160, and I get 393.75, but I can't have 0.75 students, so I round that and say it's approximately 394 students. Our next question asks, what percent of students polled said their favorite flavor was mint chocolate? So I have 15 out of my 160 students, and I'm going to multiply that by 100 to make it into a percentage. And again, notice it says to round to the nearest whole percent. So I take my calculator, come over here, and I divide 15 divided by 160, and then I multiply by 100, and I find that it's, if I multiply by 100 would help, I say I do 15 divided by 160 times 100. Hey, there we go. 9.375. And our instructions say round to the nearest whole percent, so we would say approximately 9% of the students. Reading bar graphs critically. Make sure you pay attention to the information that might be in the questions. Our next one here says 58 people were asked their favorite color. The results are shown below. Convert each number of votes to a percent and then to a central angle. Round each answer to the nearest whole number. So we know that this total here is 58 because there are 58 people. That's the first thing it tells us right here. So I have to do 15 over 58 times 100, 12 over 58 times 100, 20 over 58 times 100, and 11 over 58 times 100. And that will give me my percentages. So I get my calculator, come over here, and I do 15 divided by 58 times 100, and I see that it is 26%, because again my instructions say round to the nearest whole number, so 26%. I do 12 divided by 58 times 100. I have 21%. I do 20 divided by 58 times 100. 100, not 1,000. And I get 34%. And then I do 11 divided by 58 times 100. And that one comes out to be 19%. You always want to go back and add these together. They do add up to be exactly 100%. Because when we're doing percentages of a whole, we have to make sure that our whole is 100%. Next, I need to do the central angle. Central angle will start off the same way. I'm going to do 15 over 58, 12 over 58, 20 over 58, and 11 over 58. But this time I'm not going to multiply by 100 because we're dealing with angles. And we're dealing with angles in a circle or a circle graph. And there are 360 degrees in a circle. So we're going to multiply each of these by 360 degrees. And that'll give us our central angle for each of these. So I get my handy dandy calculator here and I do 15 divided by 58 times 360. And I see that that one comes out to be 93 degrees. 93 degrees. My next one is 12 divided by 58 times 360, which is 74 degrees. And I have 20 divided by 58 times 360. Here I have 124 degrees. And my last one is 11 divided by 58 times 360, which is 68 degrees. Here, these all have to add up to 360 degrees, so I'm going to check those. So 93 plus 74 plus 124 plus 68, and I get that they come up to 359 degrees. So looking back through my information, 68 I rounded down to 68 from 68.27. This one rounded down. This one rounded down. That one was probably the closest to 75. So I'm going to actually, instead of putting 74, I'm going to change this one to 75 degrees because that was the closest one to actually rounding up. Now they will add up to 360 degrees. Working with the same type of problem here. says find the central angle of each given the percent in our pie chart. It says dog central angle. So dogs. Dogs are our blue section here, which is right here, 48%. So I'm going to do 48 over 100 is equal to x over 360. So I can multiply 48 divided by 100 times 360. I'm going to do the same thing. Next it asks for cats. Cats are this maroon color here, 30. So I'm going to do 30 over 100 is equal to x over 360. And then I'm going to do the fish, which is this one here, 22 over 100, which equals x over 360. So for our first one here, getting my calculator, I do 48 divided by 100 times 360, which is there. Oh, that's not the right spot. Let's try again. It's good to start back with a clear home screen. 48 divided by 100 times 360. There we go. It's 173 degrees. Next, I'm going to do 30 divided by 100 times 360. Here I have 108 degrees. And lastly, I have 22 divided by 100 times 360. And this one gives me 79 degrees, which come out to be exactly 360 degrees, which is how many degrees are in a circle. Here we're going to be going and using our graph to answer the question. It says, during which month was there a loss in sales from the previous month? So here's my previous. The months are progressing this direction right here. So here I went from 5 to 6, so that one was a positive gain. Then I went from April to May. Oh, that was a negative, so therefore it lost money. And then here it went up positive again. So it says, during which month was there a loss in sales from the previous month? So that would be the month of May. May lost some sales compared to April. Our next question here says the circle graph shows the ages of people who visited the museum last Friday. If 900 people visited the museum, how many of them were between the age of 15 and 35? Well, here's 15 and 35, and they give me a percentage. So I can do 35 over 100 is equal to x over 900. So with this, lots of different ways to work this. I could do my cross multiplication, or we can notice, hey, going from 100 to 900 was times 9. So all I have to do here is multiply 35 times 9. So I do 9 times 35, and I see that it is 315. 315 people between the ages of 15 and 35 visited the museum. Our last section here is dealing with finding patterns and determining are they linear or quadratic patterns. So the first thing I need to do is go into my list here. I'm going to clear this list. Make sure we always hit clear, not delete. And I'm going to go through. I'm going to put my x values in L1 and my y values in L2. So my x values are 0, 1, and 2. So I'm only going to put the ones that pair up with a y value. Next I have -4, 0, and 4. I'm going to go up here and hit second and y equals, because I'm going to make a scatter plot of that information, and I'm just going to put it in plot 1, turn it on, and then I hit graph. And notice here's my information here. This one looks kind of like a straight line. So therefore this one would be linear. Since it's linear, I'm going to go into stat, move to the calculation section, and do a linear regression, which is number 4. And I want to go through and I want to store this information here into y. And when I press calculate I now have my information here. It says, what is my rule? Well, my rule is going to be y equals 4x minus 3.7. If I go up here and hit graph now, I should have a line going right through those points, or pretty close to it. Whenever I did my calculations, notice I have an r squared value. This one is a 0.97. This one is a really good bit, because if my r squared value is the closer to 1 it is, the better the fit. Well, this one is 0.98. This is a really good fit. It is almost exactly spot on. Looking at our last example we have right here, we're going to go and put this information into our stat list again. I'm going to look at my x values. I have 0, 1, 2, and I need to go back and add the value of 3. This one has an extra point. My point values are 7, 8, 11, and 16. I need to go into my y equals and clear out the equation that I'd already placed there from the last problem. Now when I hit graph, I should have a scatter plot that's not even fitting on here. I need to go change my window. My lowest y values are 7, so I'm going to go and change this to become -1 and then 20. That way I can hopefully see my scatter plot. And there. And this one has a little bit of a curve to it. Since it has a little bit of a curve, it looks like it might be quadratic. So we're going to do a quadratic regression. So I hit Stat, move to the right one place for Calculate Quad Reg, which is our quadratic regression. L1, L2 is good, and I'm going to go store my equation again into my y equals. So I move to here, and I tell it to calculate. And here is my equation. So this one, my rule is y equals x squared plus 7. And this one is a perfect fit because r squared is 1. And now if I hit graph, I should have a nice parabola to go along with my scatter plot. Pay attention to what you're doing. Use your technology, but do not rely completely on our technology to get everything done. Good luck.